We are going to focus on our first method of solving quadratic equations, which is factoring. Factoring is the reverse process of distributing, and distributing focuses on multiplication, so we can think about factoring using the concept of division. And we always want to focus on first looking, do I have a common factor that I can factor out? And that is identified by finding the expression of the highest degree that divides evenly into our polynomials. And reminder, a polynomial in the variable x is a finite sum of terms of the form a times x to the n. And we can also look at factoring by grouping. So let a, b, and c represent real numbers where a is not equal to 0. This will define a quadratic equation in the variable x if we have a times x squared plus b times x plus c. And because this is of degree 2, a quadratic equation will always have two solutions, which may be real or they could be imaginary. And by factoring, we're going to be using the zero product property that says if m times n is equal to 0, then either m is equal to 0 or n is equal to 0. For our first example, focusing on factoring, we have x squared minus 7x is set equal to 0. So we need to take time here and recognize we have a greatest common factor for x squared and 7x, which is x. Those two terms have an x in common. So we can factor out an x from x squared, leaving us with x, minus we can factor out an x from 7x, leaving us with 7. Still set equal to 0. Now we'll use the zero product property that says if x times x minus 7 equals 0, then either x equals 0 or x minus 7 equals 0. So a solution could be x equals 0 or x equals 7. So two potential solutions are x equals 0 and x equals 7. Now we should still check this. So with x equals 0, 0 squared minus 7 times 0 gives us 0 minus 0, which is 0. So this shows that 0 is indeed a solution. And for our second check, 7 squared minus 7 times 7 gives us 49 minus 49, which is again 0. So both of these are indeed solutions. Your first question is to solve by factoring x squared plus 3x equals 0. Our next example is to solve by factoring the trinomial x squared minus 7x minus 8 set equal to 0. Notice that a is 1, b is negative 7, and c is negative 8. So we're looking for factors of negative 8 that add to be negative 7. So x squared has the factors of x and x. And the factors of negative 8 that add to be negative 7 are negative 8 and positive 1, which helps us with our operations of minus 8 and plus 1. So x minus 8 equals 0, or x plus 1 equals 0, which gives us solutions of x equals 8 or x equals negative 1. And I want you to do both checks. I'm going to do one check with you. I'm going to check with the negative 1 just because it's a touch more complex. So this gives us negative 1 squared minus 7 times negative 1 minus 8 equals 0. Negative 1 squared gives us a positive 1. Minus 7 times negative 1 gives us a plus 7. And 1 plus 7 is 8. And 8 minus 8 is indeed 0. So I'd like you to spend some time also making sure that x equals 8 is also a solution. And just as a note, quadratic equations do not have extraneous roots or extraneous solutions. So no extraneous roots for quadratic equations. If a solution does not check, that means somewhere along the way we made a mistake, either in the check itself or in the solution. So make sure you know it should always check. Our next example is very similar to example number 2. But notice now, while A is still 1, B is now negative 8, and C is positive 7. Now because our C is positive, but our B is negative, this must factor of the form x minus, x minus. That will produce a positive C, but a negative B. So factors of 7 are only 1 and 7. And notice minus 7x minus 1x does produce minus 8x. Negative 1 times negative 7 produces positive 7. So this is factored correctly. X minus 1 equals 0, or x minus 7 equals 0, meaning our two solutions are 1 and 7. And take some time, please. You have 2 checks. I'd like you to do this on your own. It's very good practice for you to do. Your next example for you to do on your own is to solve by factoring x squared plus 3x minus 4 set equal to 0. The next example that we're going to look at is to solve by factoring 6 times x squared plus 25x plus 14. And I'd like you to notice that A is now 6 and it's not prime. B is 25. C is 14, which is also not prime. So this example is more complex. So we are going to tackle the process of factoring by groups. And in order to do so, we're going to utilize what is called the AC method. This is going to cut down on frustrations. So A is 6. C is 14. So AC is equal to 6 times 14, which is 84. So now we're going to investigate factors of 84 that add to B, which is 25. So let's start investigating 84. So I'm going to go as far away from factors as possible, meaning the farthest is 1 and 84. But that adds to be 85, not 25, so that's not our pairing. Getting closer, 2 and 42. But that adds to be 44, so that is not our pairing. 3 is not a factor. 3 is a factor. 3 is a factor of 84. So I made a little mistake there. 3 is a factor of 84 because 3 times 28 is equal to 84, but that adds to be 31, not 25, so that's not our correct pairing. And the next pairing is 4 and 21, and that's what we were searching for because 4 plus 21 is 25. So what that means for us, so I'm going to circle that. 4 and 21 is what we're looking for. So I'm going to come back up. So what we're going to do here is we're going to leave 6 times x squared alone. But we're going to take 25x and we're going to split it into those two pieces of 4 times x plus 21 times x. There's our 25x. And then we also have our c, which is 14. So I want you to take a moment and process that. That is the same as the original, isn't it? All we have done is taken that middle term and separated it. So we can now factor by groups. So looking at the first two terms, 6x squared plus 4x has a GCF of 2x. And when we factor 2x out, that leaves us with 3x plus 2. Now the operation of plus comes along, but now we're going to look at the second group of 21x plus 14, which has a common factor of 7, and this is where the magic happens. This is so cool. When I take out 7 from 21x, that leaves me with 3x. Plus, when I take out 7 from 14, it leaves me with 2. And do you see that we now have a common factor of 3x plus 2? And when I take 3x plus 2 out, it leaves me with 2x plus 7. And now 3x plus 2 equals 0 when 3x equals negative 2, or x equals negative 2/3, or 2x plus 7 equals 0 when 2x equals negative 7, or x equals negative, that looked bad, negative 7/2. And I think it would be good for us to do one check together. So I'm going to move here. I'm going to just choose to check this negative 2/3. So I'm going to go to the original, 6x squared plus 25x plus 14 is supposed to be equal to 0. So we have 6 times negative 2/3 squared plus 25 times negative 2/3 plus 14. Just take it slow. So notice the first thing we have to concentrate on is the square. So negative 2/3 squared. A negative squared is a positive. 2 squared is 4. 3 squared is 9. Now we have plus, but notice we have 25 times negative 2/3. So this will actually become minus. And 25 times 2 is 50. And this is over 3. Now for the first part, we want to notice that we have a 6 in the numerator and a 9 in the denominator, which both have a common factor of 3. And so 3 goes into 6 twice, 3 goes into 9 3 times, and 2 times 4 is 8 over 3 minus 50 also over 3. And we still have plus 14 equals 0. We're almost done. 8/3 minus 50/3 is negative 42/3. And lo and behold, negative 42 plus 3 is negative 14. And negative 14 plus positive 14 is 0. So I would like to leave it with you. I want you to also check to make sure that x equals negative 7/2 is also a solution. And so I'd like you to tackle the next problem. As always, if you have questions, please see me, but solve by factoring 15 times x squared plus 26 times x plus 8.